All right. So guys, so we said that as we go down a group, the distance is more important. Distance is the dominating factor, right? Distance is the dominating factor, while number of protons doesn't impact that much. You have to know why. All right? How do you know to explain that? So, as you all the answer key to this whole worksheet is given on blackboard. All right? It's written out in words, but let's try and understand this right now. So, as you go down, the number of energy levels increase. Is that right? Are we good? So, this is the positive nucleus that is attracting the outermost valence electron. Correct? Correct?
Yeah.
So each layer of electron inside, it's a layer of electron. Is that right? Each layer of electron, these electrons that are inside are called core electrons. What are they called? They're inside the core. And that one will be called the valence electron. The outermost shell is the valence electron. Is that right?
So if there's like more than one, there's more than one core electron.
Yeah, more the number of rings, more the number of core electrons. Correct? So, in this case, let's say there's one more core electron. Are you with me? There's one more ring set. Okay? Each circle is a layer of core electrons. Okay? So, when you go down a group, the number of core electrons increase. Yes or no? Or in other words, the number of energy levels increase. Correct? Each energy level acts like a shield. The electron is negative. Yes or no? The valence electron is also negative. Negatives kind of repel each other. Yes or no? So this layer of core electrons shields. You know what a shield means? Shields or prevents the nucleus from attracting the valence electron. Does that make sense? The core electrons act as a shield and prevent the nucleus from attracting the valence electron. Does that make sense? The core electrons act like a shield and prevent the protons in the nucleus from attracting the valence electron. Okay? So this is known as shielding effect. What is this known as? Shielding effect. Students should know when I say shielding effect, they should understand what it means. Okay? So the shielding effect overpowers the increase in the number of protons. Say you are increasing from 3 to 11 to 19 protons. All right? Does the outermost valence electron feel the power of 19 protons? Is it able to feel it? No. So, what the outermost valence electron feels is the effective nuclear charge. What does it feel? Effective nuclear charge. An effective nuclear charge is always less than what the real nucleus charge is. Does that make sense? This outermost valence electron does not experience the force due to 19 protons. It experiences a far lesser force. Why? Because of the presence of shields, which are the core electrons. Is it making sense? Are you understanding? So, if I were to give numbers and explain this, say 19 protons have a nuclear force of 8.2 times 10 to the negative 18 newtons. All right? 19 protons experience that should have that much force. But because of the presence of the shield, will the valence electron experience that much force? No. It's going to feel much less force. So the effective nuclear charge could be a number much lesser than this, something like 5.1 times 10 to the negative 18. Does that make sense? it becomes much lesser. So, because of the force being lesser, the distance is the dominating factor. The number of increased protons do not lead to an increased attraction. Do we understand this? So, do you understand what shielding effect is and what effective nuclear charge is? Do you all understand this? Whereas, if you go across a period, when you go across a period, does the number of shells change? Do the number of shells change across a period? They don't. What is the only dominating factor? The number of protons. So the shielding effect is going to remain constant as you go across a period. Yes or no? It doesn't change. The shielding effect increases as you go down a group. Yes or no? Because the number of shields increase. Whereas the shielding effect is constant as you go across a period. But what increases inside the nucleus? The number of protons increases, so the effective nuclear charge increases as you go across a period. Yes or no? The effective nuclear charge, so what is the pattern in effective nuclear charge? It decreases going down and increases going across. Yes or no? What is the pattern in shielding effect? Shielding effect increases as you go down. What happens as you go across? It remains constant. Yes or no? Do you understand all these things? Do you understand these patterns? Okay. So I'm going to... Any questions? Yes, Daniel.
Wait, the core electrons are like a shield, right?
Yeah.
And they're beautiful.
Yeah.
But they get
Yes, they are being attracted to the nucleus. But they repel the other layer of core electrons, correct? Because this is negative and that's also negative. Correct? It kind of becomes like a shield for the one that's further away from us. Right? Because the negative repel.
Yeah, but then wouldn't it like attract?
The first layer, yes. When you come to the second layer, the shield has already been made.
So why are they drawn like that?
What is the... Oh, you're scrutinizing my drawing? What are you saying about the drawing? Yes. Okay. Are you understanding what I'm trying to say?
Yeah.
I did not have drawn it perfectly the way you're trying to understand it, but you get the picture. Okay. Yes, Natalie.
Say there are a lot of like rings and what
Uh-huh.
would core electrons then be shielding their other core electrons?
Yeah, each layer of core electron shields the other layer from getting attracted to the nucleus. Does that make sense? Each layer is now a shield, so this will get less attracted by this nucleus because of the presence of this. This will get even less attracted because now there are two shields that prevents its attraction. Okay? Yes.
Okay, for the arrows, what are you saying? Like,
What arrows? Yeah, this one?
Yeah, what are you
It's the
saying?
trend when you look at a periodic table.
Yeah, but what are you saying increases and what are you saying like stays constant?
The shield, the number of shields. When you go across, the number of circles are the same. So the shields are the same. So shielding effect is constant.
What about going down?
Going down, the number of circles increase. That means shielding increases.
Okay, what about
So the effective nuclear charge is how much of the power of the nucleus it feels. That power depends on the shield. If the shields are more, the power is less. So effective nuclear charge decreases going down.
the shields on board?
The power of attraction is less. The power of attraction of the nucleus for the outermost valence electron. Force of attraction. Yes, Stephen. All right? And then, because the shields are not changing, but the number of protons are increasing, the effective nuclear charge increases across the period. The number of protons are increasing. So the number of protons as you go across increase, but the shields are the same. Since because of the increased number of protons, the effective nuclear charge increases. Yeah.
So the protons increase.
Yeah, if the protons increase and the shields remain constant, the effective nuclear charge is going to increase. or the force is going to increase. The force of attraction is going to increase. Are we good, guys? Do we understand all this? Okay, I'm going to stop this recording at this time, and